So dear ladies and gentlemen, dear IABSE friends, I am pleased to welcome you to today's webinar about risk management of large-scale projects. My name is Alfred Strauss and I'm from the University of Natural Resources and Life Sciences, and I'm heading the IABSE GR Austrian group. I have the honor to moderate this webinar together with Dr. Evie Apostolidi from University of Darmstadt. So the webinar is organized by the International Association for Bridge and Structural Engineering, and it is organized together with the IABSE group, the National Group of Austria, with my co-chairs, with Dr. Alois Vorwagen from IED, who is participating today in the beginning, and Dr. Roman Geier from Schemeta Consult. So we'll hand over to Evie for the mission, for the general wording.
Hello from me as well. I don't say good afternoon because I'm hoping that you are watching us from all over the world. I will just say a few words on IABSE. IABSE's mission is to exchange knowledge and advance the practice of structural engineering worldwide. And this is mainly accomplished through the Structural Engineering International Journal of IABSE, the IABSE bulletins, the structural engineering documents, the case studies, documents, and the guidelines, and of course through the conferences. And the upcoming conferences of IABSE are going to be held, the first one in Ghent in September, and then further on in Prague in May 2022, and then the next one in 2022 is in Nanjing. Please visit the IABSE website if you would like to get further information on the conferences. I would like to inform you that this session is being recorded. You might be probably aware of that. And this also goes live on Facebook. And afterwards, it will be uploaded to the e-learning platform of IABSE. Now, going to our webinar today, we are kindly asking you to place your questions in the Q&A section of Zoom. And after Professor Bergmeister's talk is over, we will coordinate the discussion and we will address your questions to you. So, Alfred, back to you.
Thank you very much, Evie. So it's a great pleasure for us for today's webinar about the risk management of larger scale projects to have Professor Bergmeister here as a speaker. Professor Bergmeister is head of the Institute of Structural Engineering at the University of Natural Resources, so from the same university as I'm from. And his practical as well as scientific excellence has been recognized already by a lot of doctorates and awards. What we also have to mention, he is editor of Betonkalender, Journal of Beton- und Stahlbetonbau. And so these are only one small things in his bigger spectrum of excellence. He's also responsible for planning and construction of large structures like the Brenner Base Tunnel and the Brenner Motorway. And now he's also involved in a lot of scientific projects and practical projects. So he also, what is very important to remember, he is a member of the Berlin-Brandenburg Academy of Science, member of the German Academy of Science Leopoldina, and member of the scientific board of the Helmholtz Center in Potsdam. He holds also already 3 honorary doctorates, so it is a very impressive track. Yeah, dear Professor Bergmeister, dear Konrad, we are happy to have you here for today. We're looking forward for your presentation and that we would like to ask to share with us your experience and your ideas and vision with us. So we would like to ask you to give us your speech, please.
You are on mute, please.
So now, okay, dear Mr. Chairman, dear Alfred, dear EFI respected members of the panel. Risk management of large projects leads immediately to some modest behavior. Therefore, I would like to outline in the next half an hour approximately certain risks which may occur during the planning and the realization phase of infrastructures, the opportunities as well. And I feel it is very important that we see always both sides on the picture. Then I would like to concentrate my presentation specifically to the so-called unknown unknowns, which are related to unexpected extreme events. I will try to present special methods which have been developed in the past year, and finally conclude my presentation approximately 25 to 30 minutes. I wrote a book regarding these issues, unfortunately only in German. It is available now since a couple of months, and it was produced by the editor Ernst & Young, Ernst & Sohn from Berlin. Now, going a little bit more into detail, when we are talking about extreme events, then as a human being, we are always trying not to think too much on such extreme. Normally, in our behavior, we are relating extreme events to some negative issues. There is one other, almost a psychological issue happened when a single severe events occur. Then we are perceiving that as a very extreme events. If a huge number of small events occur over a certain period of time, then we are not care about. This might be happened if you are thinking on some street accidents. If one single accident occurs with more than 100 deaths, then we are talking about that. We are trying to search about these causes and so on. But if one event of street accidents happen during a whole year, then we do not normally care about. Then there is another issue which is related to the so-called unknown opportunities. There are not only risks, there are also a lot of opportunities happen. In the next couple of minutes, I would like to outline a little bit the different situations. So normally we are talking about risk, but on the same hand side, we have also chances which have to be identified, which have to be in somehow followed, and we have to do something with them. Now, Cicero, the Italian philosopher, almost more than 2,000 years ago, stated, how much did we really learn from the past? And he says that history is the only teacher of our life. And that means that we have to see if we are able through a process, and I would like to outline now this process a little bit, if we are able to identify, to define some areas which might create in the next steps some risk or some opportunities. This is the scope of the following presentation. We are used and we are trained as a civil engineer for a certain, let's call them probability-based acceptable risk procedure, dealing with stresses, with actions and dealing with resistance. And we found, it was Hasefer Lind who published the first paper on that. He found a certain safety margin expressed in a value. For example, 4.7 referred to a probability of failure to 1 to the power to 10 to the power of -6. One event of in a period of 1 year out of 1 million of projects or possible structural failures and so on. So this is a very low margin of acceptable risk. This is very well known for structural design, for structural purpose. On the other hand side, we are accepting almost on a daily basis that approximately 1.5 times 10 to the power of 5 of street accident might be happened on European highways, on European streets. And in the past periods, we concentrated not only our research, but also our interest to the so-called life cycle management. And now it comes into the discussion a second issue, which is the time. Every acceptable risk must be related to a certain period of time. Certainly, during a construction, we have a very clear time step, which is the construction period, or during the planning process, we know that we are referring to the planning time. About in the operational phase, we have to refer everything to the so-called operational time, which might be 50 years, 100 years, or also more for certain buildings and infrastructures. Now, today we want to talk a little bit about extreme events. And extreme events are not easy describable with some statistical distributions. So this figure, this scheme tells us a little bit that the extreme events can be also described as the so-called fat tails. They are occurring very in a huge extreme impact, but the time period can be very long. So that means the probability of occurrence will be very, very low. And this creates us also from, let's call them a statistical standpoint of view, from an engineering standpoint of view, also some difficulties. It is known as the fat tail in the statistics. Now, the actual risk management is based on the identification and on the evaluation of certain risks. And finally, we are taking some measures in order to reduce the impact and in order to keep the possible impact under a certain value. And we are always talking about the risk and the so-called chances. The positive issues on the actual risk management is the following, that we are able to identify and to quantify the impact. But we are not able, through the actual procedures, to somehow to identify or to define also the impact in terms of costs, in terms of times, of the so-called extreme unforeseen events. And finally, the society, the press, and also individuals are after, if something occurs, always on the search for some guilty party. Somebody else has to be guilty. So this makes the problem quite opportune. And therefore, we should try now, this is the scope of the presentation, in somehow to describe this behavior. The extreme events occur, as I told you, they are not time depending, they are not periodically coming up, they are unforeseen. So that means that something is happened which we don't know. We are talking about extreme events. We are talking about unknown impact. And till now we learned that we are not able to determine the so-called extreme events with unknown impacts on a statistical basis. This is what we learned till now. Now, are there any methods or approaches around which can be, theoretically speaking, used? We are talking about interdisciplinary methods, and they have been used very often in psychology, in social sciences, economical sciences. We know the statistical methods. We are using them, the statistical methods, in order to figure out a certain probability of occurrence. And I tried to develop a so-called phenomenological approach, which will be described immediately. Now, in order to create a little bit more of order within the whole risk discussion, I tried to categorize the whole risks in terms of the so-called known risks. So risk and opportunities which are known based on the actual information what we have. Then the second category is the so-called quantifiable risk and identifiable risk. The third category is the quantifiable but very difficult identifiable. The fourth one are the not identifiable risks. And finally, I tried to define 3 more categories. The first 4 have been already known. 3 more categories which are related to human-induced events, events which are induced by nature, by technology, by the economy. And in terms of the economy, I would like only to remember of the impact what the world got in 2008 when an American bank failed. So this was an impact which was unforeseen, which had a huge impact, not only nationwide, but it had an impact on a worldwide level. Or if you are talking about, health, we got an impact by the last pandemic, which was never foreseen, which was not describable before we had this big impact. And now we know a little bit more. There have been only 1 or 2 countries on a worldwide level who have been at least a little bit prepared by having certain procedure if a certain pandemic occurs. Finally, the last class, the last category is the combination of different, let's call them risks, a so-called chain situation, chain events. I give you now in the following a couple of examples for that. Before we are going into the detail, I would like to refer to you a little bit what we are doing at the moment. We are identifying the risk by normally or within a so-called Delphi process, trying to ask experts, getting the expert opinions, quantifying the risks, and we are nothing else as we are using a product by the probability of occurrence times the impact of a certain risk, of a certain opportunity, gives us a certain amount of euros, of dollars, which have to be reserved if a certain risk occurs. So we're trying to cover the so-called probability-based risk with a certain amount of financial guarantees, nothing more, nothing less. Now, we are aggregating the individual risk if there are a lot independent risks. So this is always a question, is the risk are real, independent or not? But we are assuming that they are independent, otherwise we have to use a correlation matrix. And we are trying to develop some measures in order to reduce the impact of the risk. This is the actual procedure. Now, are we able in somehow to use the existing methodologies? This is the question. The possible quantitative methods are already known. This is the variance method, the Monte Carlo methods, some sampling methods, and so on. But finally, if we are using a Monte Carlo method, figuring out, let's say, the VAR value, the value at risk percentage, then we have to interpret it and to communicate it. Now, in order to summarize that again a little bit, we are identifying the risk and the opportunities. I feel sorry about the spelling errors. We are using the products over here. We are aggregating the individual risks. And finally, we are presenting that, or it can be presented in a very simplified matrix, 3 by 3 or 9 by 9, identifying different categories in terms of probability of occurrence and in terms of financial capital. This is actually what we know already. Now, for the unknown risks, there are no procedures around. What we did over here was, through the PhD thesis of Alexios Stamparopoulos, who finished his PhD now almost 8 years ago. He worked out the most convenient statistical function for the aggregation of a lot of different risks for large-scale projects. These have been worked out by Alexios, and he came up with a so-called beta function. So the beta distribution is the most appropriate one in order to describe the aggregation of risk for large-scale projects. This is an additional information. What are we doing with that? We are trying to identify, actually, finally, by using the so-called Lorentz curve, a certain value at risk value. The VAR, the value at risk, can be referred to a 50% or an 80%, sorry, there should be 50%, an 80 or a 50% percentage, and this is actually something which has to be decided finally by the owners, by the project manager, by the project drivers, if they want to cover with the actual statistically derived financial, let's say, cover 50% of the probability or 80%. I wrote in my book that specifically for publicly owned large-scale projects, the tendency is to cover approximately 50 to 70%. Privately owned, very complex projects, and complex projects can be also small projects. The tendency is going to a higher value from approximately 80 to 95% of the value at risk. Now, the new approach is referring, the so-called phenomenological approach is doing something different. If you have over here the presence, then we are trying to look back in the past, trying to figure out what was happened in the past. For example, if a natural hazard have been happened in the past 100 years in a certain area of our project. Large-scale projects are projects which are huge in terms of complexity, in terms of development, in terms of their length or of their height or of their costs. Now, you can try to figure out from the past certain phenomena which finally were leading to a certain event. And we are trying to use that information, adding to that information some actual monitoring, trying to integrate probably some simulation results, and trying to develop a prognosis for the future. This is the concept. So the concept uses past experiences. In a technical term, we would say a Bayesian approach. Past informations enriched with some actual monitoring, with some measurements which are taken certainly always on some defined key elements which are derived from past events, and then they are trying to learn from the history and do the prognosis for the future. Now, for the three extreme risk categories, there are certain different types. The first one is the so-called unknown human-induced risk. The second one is the unknown risk induced by nature. Sorry? Is there any question? There's risk during the design. So I will respond to the answer which I read over there. Do performance-based design a specific way to address risk during the design phase? Yes. The performance-based design would include, and this is also a big advantage for the performance-based design, they can include and should include not only certain different risks in terms of the environment, in terms of the logistics, in terms of the construction and realization phase, but they should include also the so-called unknown extreme possible events. Thanks for the question. So the idea is now to categorize, as I told you already before, the whole package of unknown risk into 3 different topics, into 3 different thematics. The first one actually is something which is related, and you see it only again. This is already a picture of what you saw. Now I'm starting with the first example for the so-called human-induced event. We remember 20 years ago, on the 11th of September, a terrorist attacks occurred on the Tower of New York, on the World Trade Center. And what we really learned was that finally the building and the whole structure have been properly built and designed, but it has not been included, and it couldn't include such a major terrorist attack or such a major event. What we can learn out of such a study is nothing else that there was also a certain chain of different failures. For example, first of all, a part of the tower collapsed. Then some fire came in. And finally, the fire and the high temperature reduced the steel resistance of the main structure, and finally this led to the collapse of the floors and the collapse of the outer the perimeter columns as well. The whole structure collapsed. Now, what we learned out of this example was that we need a certain robustness. Robustness was developed later on, and robustness is a topic which must be specifically for structures, infrastructures, and I call them complex buildings, must be included on a design in the design phase. So this is something what we learned. The second issue, the technology-induced risk. We are running quite often such problems, and we don't know that. Corrosion, environmental impact, sometimes also aging of the material and so on is going on. Our structure, specifically in Europe, have an age of the existing structures of more than 50 years. They have been built more than 50 years ago. Now, only a few of those structures have been designed in order to get a certain robustness. And I'm not going into detail of this specific topic, but I would like to figure out only that the so-called technologically extreme events are very often related to or some unknown situations during the design phase, probably also some neglection of possible influences or impacts, and finally also some not respected and non-included possible extreme events during the realization phases. Robustness is again a big issue. As the third possible extreme event, I would like to mention the Fukushima earthquake now 10 years ago. And this was certainly a nature-induced extreme event, but finally that extreme event was not only one event, this was a chain of various different events. And if we go a little bit into detail, then we see, without going too much into detail, but I would like to point out first some other issue. Then the earthquake with a certain magnitude of 8.9 actually had an impact on the nuclear power plant. First of all, and I wrote it over here, on the tsunami, and later on the nuclear power plant. So based on the research done by Roske and published in 2018, the frequency of a possible damage for nuclear power plant is approximately 10 to the power of -3. So that means one event occurs on a worldwide level 1 time per year. This is not very low. But if we look to the chain of the extreme events, then an earthquake occurred with a high magnitude. And this has happened, I wouldn't say often, but this has happened on a worldwide level. The earthquake induced a certain tsunami. Also, this has happened. And finally, the tsunami ended up in a nuclear accident where a lot of people have been killed and so on. The only measure what we can take is we can try to interrupt the chain of possible events. So the sequence of possible extreme events. And this have to be studied carefully. There have been different small issues which are very interesting to identify and to analyze them. The pumps that kept the reactor cool broke down. So there do not have been a redundant pump system available. Then for a whole day, the workers tried to keep the reactors cool. I mean, we had a similar situation also very close by in the Czech Republic another 20 years ago. And the overheated system finally exploded. And this led to the radiation and finally to approximately 20,000 fatalities and more than 180,000 people which have been killed. Which have been displaced, which had to be displaced. So 20,000 fatalities. Now, what we learned by analyzing this extreme event is that we need something to interrupt the so-called chain of extreme events. And this is something which is very important. Now, in the literature, there have been some interesting people, Steinmüller, Nicholas Taleb, and I met him several times in order to reflect with him the approach what I was now a little bit trying to start to develop. Also, Professor Sonnet from ETH and EPFL from Lausanne, from Switzerland, he came up with the dragon, the red dragon, and Taleb, Nicholas, Nassim developed the idea of the black swan. So there are on the description of such big events. It was actually Sonnet who developed the exponential function as a possible description of extreme events. He simulated certain extreme events and he came up by using some exponential function, and he was also quite satisfied that he was able at least in somehow to identify by using a statistical function the extreme events. I was using a different approach, and I need another 5 minutes and I'm done. How such an event can be described. The scope and the idea is now the following. We want to identify also the unknown risk and the opportunities. We want to search in the past, and the new approach is nothing else as searching in the past, studying carefully what was happened by similar projects, in the surrounding areas and so on, applying certain measurements based on key factors and developing an idea how such unforeseen extreme events in the future can be or promoted in terms of opportunities or reduced when some unforeseen risk would be happening. This is the scope. The normal projects are quite simple, and the impact of a very extreme event on a normal project probably might not be so intensive as it is for a large-scale project. Since the complexity, the volatility is increasing exponentially, and this makes the life so difficult when we are talking about large-scale projects. Then there is another issue, which is related to fear. We experienced that also during our past, during the past pandemic. And we figured out that fear was something which is something which cannot be very much, let's say, limited. almost the whole world experienced now the pandemic. And there is still some fear around in terms of, are we able, through the vaccination, to protect ourselves? Martina Lebotzi-Mühlberger wrote a book a year ago, and she said the fear remains even afterwards, invisible, everywhere at all times. This is something which has to be not underestimated, and therefore we have not only, and this is now the procedural way, how we can probably try to identify some unforeseen events. We have to observe the natural past events, the environment, also the extreme world events, the processes which are going on through the digitalization and so on. Observation phenomena, developing scenarios by using expert systems, computer simulation, experts, operational research, and so on. And finally, trying to identify the so-called catalytic elements. We normally call that key performance indicator, in order to use a word which is already known in the civil engineering world. Identification parameters. And the so-called catalytic elements, they are based on historical experience. They can be figured out through the simulations. And finally, we are describing a possible extreme scenario. And we will develop different scenarios and trying to identify key parameters which can be observed. By going so in that directions, we are applying a periodic monitoring for those key parameters. And this is very important, we have to discuss and we have to reflect that also with experts, for example, or also with the project responsibles itself. This is very important. Otherwise, we will not be able to study that carefully, since we need, in any case, the interaction with the actual project manager talking about large-scale projects. So, periodic monitoring, reflection and communication, and finally, defining some preventive measures based on the studies, based on the monitoring and so on. And we have to provide equipment and human resources, both. This is a very important issue. Let's think for a second to the chain event in Japan, now exactly 11 years ago, on the 11th of 10 years ago, on the 11th March of 2011. In order to prevent such a chain event, we need some measures which can be applied immediately. We need some information from the monitoring, and we need both equipment and human resources. Now, in terms of costs, I tried to develop a procedure which is also published in the book, by saying we need for a certain project not only the analysis of the so-called basic costs and the analysis of the so-called identifiable and quantifiable risks. There is a certain amount of acceptable risk. We are accepting that. And I introduced my presentation with the acceptable risk. But we have to include also a certain percentage on the basis of the basic costs, which are in a percentage of up to 11%. I analyzed different projects. I did a back analysis of the past projects, and I came up with some procedure in terms of complexity of the structure, in terms of the construction and the planning period, in terms of possible formation of chains of events, and certainly there are different values refer to the different time steps of the planning and construction and realization phases. So the maximum amount is 11%, the minimum amount is 3%. There is a range between 3 and 11% of costs which should be foreseen in the forecast for large-scale projects. And in order to conclude my presentation, we need tolerance. The tolerance between the different people. This is an example where I was responsible for years ago. We had a site work going on with 11 different languages. Or you need also trust and very often communication, which allows people which are not talking, which they cannot talk since there is a lot of rumors around. They have to trust each other, and they have to find a way how to communicate together. And finally, we need courage in order to accept still some risk and some opportunities. And I would like to thank you so much, and then I'm open for the ongoing discussion.
So, Professor Bergmeister, Konrad, thank you very much for the very interesting presentation. I think it's a very trendy topic. We'll move on to the discussion. So the discussion in the chat or are welcome to write us here your questions. Yeah, I think they will come. May I start with the first question? So with respect to these are now the unknowns, knowns, the risk and unknown risk and so on. Do you have a specific idea about education programs, how universities or even schools or and so on should already teach the future generation such topics?
So thank you so much, Alfred. This is a very interesting issue. If you remember, before 2008, in economical science, they have been not so aware about possible unforeseen extreme financial events. After the failure of the Lehman Brothers Bank, a lot of new topics came in the study program of the economical science. Now, we experienced in the past year, and we don't know exactly the reason, that a lot of additional extreme events came in. If you think only, for example, on the digitalization process. And so I'm sure that we should include in the bachelor and as well, specifically in the master program, some dedicated hours to, first of all, to present a model, to present different approaches which can be used. Secondly, to discuss with the ongoing responsibles, engineers and so on, these topics. And third issue, we should experience that also by training. That means working with the students together and work out programs. Using a project, trying to identify some risk, trying to identify some possible measures, which kind of key identification factors could be used, and so on. And this helps a lot in order to be aware about such an unforeseen event.
What do you think about databases? Using databases, can they help in particular to understand the specific processes and so on? And what is your opinion about such an approach?
Now, this is another very important issue. Databases are very helpful, but they are only helpful if the individual events are described very well. So that means that we need the background, the constraints, some elements which led to that specific event. And second issue, what have been done afterwards? If we are thinking on the collapse of a bridge, then we are trying to adapt certain measures like studying the robustness, promoting integral structures and so on. And that issues should be integrated in the data bank, and they could be used in the future by applying, let's say, artificial intelligence algorithm in order to train a data bank and to figure out from the data bank exactly that historical events, what we need in order to do a prognosis for the unforeseen events.
Thank you. Thank you very much.
It seems that we don't have any questions yet. Please feel free to ask.
Yes, there are two.
Okay, there is one question. How to estimate the level of robustness needed in the structural design? I was also aiming to ask about robustness. I mean, robustness is a webinar on its own, but okay, so sorry, I addressed the second question instead of
no,
the
don't
first
worry,
one.
Efi. I read already both questions, so I will respond the second question, then come back to the first one. In terms of robustness, I mean, Alfred knows that very well. There exists a lot of different approaches, but till now, there is in the code, there is not an accepted approach available till now. What we are trying to do is actually we are trying to see if in a certain structure, if one, let's say the most critical member fails, then the structure must keep still safe. So the structure should not fail and should not collapse. And this is a very rough description how we try to achieve robustness, but robustness must be not only referred to the so-called structure itself, but the robustness is also something which is going into resilience. If we are thinking on a corridor basis, where we have some bridges, some tunnels, and so on. If a train goes from a bridge to a tunnel, and afterwards again to another bridge, then you have a chain of individual structures. And for the corridor, it is important to have a certain resilience. Or if a certain element of a structure fails and you have to close the corridor, then you should have a bypass, or at least a possibility that the train can bypass the failed situation, or the cars can bypass that. This is an issue which is very much important. I don't know, Alfred, if you want to add something.
No, I think you already addressed this question very well. So there are a lot of different variations of and formats for the robustness, but still it is not an full determined value how you should define the robustness level.
Then the second question related to social factors. I would like to thank Mr. Hashim that he presented this question. This is such an important issue. The social and the psychological behavior of human beings is very important. It must be included in that proposal, in that project. I included that in terms of, let's say, there are a lot of different individual parameters, or let's call them elements, which are governing the possible prognosis for the future. And the governing factors might be how robust is the structure, what will be the behavior of the people involved in the immediate reaction, what about the social behavior and the psychological behavior, let's say 3 hours, 6 hours, 9 hours later of the event. Since this is another important issue, if you are able not only to find, let's say, some safe bypass or some other measure which might be applied, but also the human behavior is quite important. So this is one aspect which should be really reflected, and we should also include it in our study programs. How we behave, what can we do with fear, what can we do with the social aspects.
Thank you. We have a next, thank you very much for answering. A next question, are the contractors, engineers today taking into consideration the risk that could face?
Thank you so much for this question. I can tell you only that the European community, the European Commission, which is observing the trans-European network projects, are aware of these issues. And I'm chairing a group called the Chefs of the Long Tunnels, and we have been facing also this problem. since they are not recognized till now in codes or in guidelines. There are now some discussions going on in the so-called historical countries in Europe, which have been promoting tunnels and so on, to include that issues as well, since specifically in tunneling, there are a lot of unknowns. You cannot inspect the geology before you excavate a tunnel. And therefore, this is a big issue. And I would say the public administration, but specifically also the European main drivers of the large-scale projects are aware of this topic. And I'm sure that in a couple of years, we have and we will include that also in our guidelines and in our procedures.
Thank you very much. Maybe one more question from my side. With respect to the risk management, you have different professions there, different groups on different education levels, and you were just in your project, you were just responsible for this risk management. So what system or what structure did you use in order to make all the groups aware of specific risk situations? I can imagine this is very complex. And
I would like to answer that with one word: modesty, and be tolerant to every opinion, and try to respect it.
Yeah. Thank you very much. Yes, so at the moment there are not any more questions, but I think nevertheless we can collect the questions, and we will then email or will contact you, and Professor Bergmeister think will be happy also to answer to just respond to these questions. So then we will say again, thank you very much for this very interesting presentation. Thank you also for supporting us in this webinar. To the organizers, I would also say thank you for the members and for the participants participating in this webinar today. And we will close here. And it's over to Evi. Perhaps you would also say some words.
Yes, thank you also from my side. I really enjoyed this presentation, and particularly this interdisciplinary correlation that's about fear and knowledge. I think this is the key in our, let's say, also in our discipline. The more we know, the less we fear, and the more problems we can address. So thank you very much, and hope to see you all soon again next webinar. And yeah, please feel free to ask more questions and check also online the recording session.
So, Konrad, thank you very much, and hope to see each other in the next webinar or next activity in the IABSE or other activities. I wish all of you a good remaining week and also a good summertime, and with this format to see you in September again. Konrad,
thank you. The same to you. Good luck to everybody.
good luck. Thanks a lot. See you then.
Bye.